Hi everyone, and thank you for joining. In this video, we're going to talk about how to describe transformations of a function when the equation of the transform function is given. Remember that y equals f of x is the equation of any parent function, and the transformations are indicated by the coefficients a, k, d, and c. Remember one very important rule before we start any transformation to a function, we have to factor the coefficient k. So coefficient k must be in factored form, otherwise you will get the wrong transformation. So first we have y equals 2 f of x minus 1 minus 8. As you can see here, we have the coefficient a equal to positive 2. Now, since we don't have any coefficient multiplying or number multiplying x, that means that k must be equal to 1. So there is no horizontal stretches, neither compressions nor expansions. We have subtracted in this case the number positive 1 which from x, which makes the coefficient d equal to positive 1. And lastly, we have subtracted 8 from the entire function, which makes the coefficient c equal to negative 8. So with this in mind, we're going to get started with the description of the transformations. Now, when k is equal to 1 or a equals 1, we don't have to describe any transformations because there are no stretches in this case. So a equals 2 means that we have a vertical expansion, and I would write in here 2 times taller. Or you can say a vertical expansion by a factor of 2. For k, there is nothing that we have to say. D is positive 1. That's a horizontal translation of 2 to the right. And lastly, we have c equals negative 8, which means that there is a vertical translation of 8 down. So next we have y equals negative f 3x minus 6 plus 4. Now, as you can see in this case, x as a coefficient, so as a multiplier. And this multiplier is not factored from the expression inside the function f. That means that k is not in factored form. So first step first, we have to factor out k. So we have negative, and then we have f. We're going to take k out, which is 3, and then x minus positive 6 is going to become positive 2, so x minus positive 2, close the brackets, and then plus 4 at the end. So as you can see, we have coefficient a equal to negative 1. We have k equal to positive 3. We have d equal to positive 2 and c equal to positive 4. It is best to list the coefficients first and then start describing the transformations. So we have a vertical reflection, or we can say a reflection over x-axis. Remember that since a is negative, the y values has been changed to opposite. So, and that happens when the graph is reflected, or function is reflected over the x-axis. So k equals 3, that means we have a horizontal compression 3 times narrower. Or you can say compression by a factor of 3, meaning that the function has been compressed 3 times. So d equals positive 2 tells us that there is a horizontal translation of 2 to the right. And c equals 4 is a vertical translation of 4 units up. So next we're going to look at this function. Now feel free to work on these questions on your own. In principle, we have explained everything so far. So again, we are in the case where k is in unfactored form. Remember that even though k is simply negative 1, that counts as a coefficient that needs to be factored. So here we go again. We have y equals 0.5, which is the coefficient a, and then we have f. So next we have negative 1, and then x minus positive 5, close the brackets, and then plus 7. So we have the coefficient a equal to 0.5. We have k equal to negative 1. We have d equal to positive 5. And then we have c equal to positive 7. So this will be a vertical compression by a factor of 2, so 2 times shorter. Next, we have reflection of the x values, which happens over the y-axis. And again, it's very important that all the transformations are stated in order. So following the third order. So d equals 5 makes this horizontal translation of 5 to the right. And c equals 7 makes this a vertical translation of 7 units up. So next we have y equals negative f 1 over 4x minus 1. Again, as you can see, 1 over 4 here is unfactored. So we're going to start off factoring the coefficient k. So we have negative 1, or simply a negative f. 1 over 4 needs to be factored before we start the transformations. X minus, now remember when you are factoring 1 over 4, number 1 is divided by 1 over 4. It's just like when you are factoring, let's say 3 here, number 6 is divided by 3 to give 2. So when you divide 1 by 1 over 4, you get 4. And then close brackets, and then that's it. Now we have coefficient A equal to negative 1. We have K equal to 1/4. We have D equal to positive 4. And we have C equal to nothing. So there is nothing added to the end, which means that we don't have to state any transformations for the vertical translations. So A of negative 1 will not cause any stretches, but definitely reflections of the Y values. Reflections of the y values happen over the x-axis. That would be the reflection line. K of 1 over 4 means that there is going to be a horizontal expansion, and the graph will get 4 times wider, or you can say horizontal expansion by a factor of 4, meaning that it's 4 times wider, or horizontal expansion by a factor of 1/4, meaning that k is 1 over 4. So again, the key word is expansion here. D is 4, that's a horizontal translation of 4 in the positive direction, so 4 to the right. And there is no vertical translations. So this is how you describe the transformations of a function when an equation is given. So remember, very, very important and an easy mistake and common mistake to make is not factoring k before transforming a function, and that is very important. Thank you for learning with me, and bye for now.